Hello chemistry students. Posting another video about balancing chemical equations since it seems to be a common area of weakness in what we've been doing in predicting reaction products. So I just wanted to go through it on a conceptual level first and then give you some examples of how to do it so that you could kind of separate the two. So balancing chemical equations, why do they need to be balanced? So the concept is that all reactions have to follow conservation of mass, in that matter cannot be created or destroyed but only converted from one form into another. So you cannot just make an atom on one side of the equation, nor can you destroy an atom going from one side of the equation to the other. All that's going to happen is the atoms are going to move around. If we have a written reaction equation that doesn't follow that, it's not physically possible. So we need to balance the equation in order to make that work. So how do we know that an equation is balanced? Well, an equation is balanced if it has the same number of each type of element on the reactant side as it does on the product side. So if we look at an example equation, like the one I have written here, which is the reaction of nitrogen gas with hydrogen gas to form ammonia. If we look at, this is the unbalanced equation. So right now, we have two nitrogen atoms on this side of the equation, but only one nitrogen atom on this side of the equation. As it stands right now, this is not a balanced chemical equation, and this was physically impossible. We cannot simply destroy a nitrogen atom going from one side of the equation to the other. And in the same way, we have two hydrogen atoms on this side of the equation, but three hydrogen atoms on this side of the equation. So a hydrogen atom is currently being created out of nothing. That is also equally impossible. So the question is, well, we know that nitrogen gas and hydrogen gas come together to form ammonia. It's a chemical process. We do it industrially all the time. So how can this be possible if the way this is written, that doesn't work out? And the reasoning behind it is we can't change the chemical formula of the chemicals going into the reaction equation, but we can change the amount of the chemicals going in, or the number of molecules going in, so that the reaction works out at the end. So here's how this works. The way this is currently written is we have one nitrogen gas molecule and one hydrogen gas molecule. As we can see, if we write them out like this, there's no way that we can take this and make an H3. We'd have to have more hydrogen in order to make an H3. So how can we make this work? Well, what we can do is we can increase the overall number of hydrogen atoms in the equation. So let's say we have 3 hydrogen atoms instead. So instead of just these 2, we use a coefficient to increase the number of hydrogen atoms. Notice how we did not change the chemical formula of hydrogen. All we did was increase the number. So what this coefficient of 3 is saying is that instead of 1 hydrogen atom, we now have 3 hydrogen atoms. Still the same chemical formula, still H2, but now there are 3 of them. So what we can do with this is we can take these 3 H's and react them with this nitrogen, and we can take these bottom 3 H's and react them with this nitrogen. So that at the end, we end up making 2 ammonia molecules, 2 NH3 molecules. So if we're making 2 NH3 molecules, we need to say that here. We end up making 2 ammonia molecules. This is a balanced chemical equation now. And it says that one nitrogen gas molecule reacts with 3 hydrogen gas molecules to create 2 molecules of ammonia. So again, important to note, we did not change the subscripts. We cannot change the subscripts of the chemicals being created because that would change their chemical identity. We're not making any other chemical formula but ammonia from this reaction. So we cannot change this chemical formula. We can't change nitrogen and hydrogen gas either because they're nitrogen and hydrogen gas. These are the chemical formulas for those. But we can use coefficients to alter the amount of each type of gas that's either going into the reaction or being created from the reaction in order to balance it. And if we verify here, we can say, okay, if we look at this, we have one nitrogen gas molecule. So on this side of the reaction, we have 2 nitrogens. And on this side of the reaction, we have 6 hydrogens. And now, since we have 2 ammonia molecules, we have 2 nitrogens on this side of the equation and 6 hydrogens. We now have the same number of atoms on each side of the equation. This is balanced. We can verify that too by looking at the image that we created over here, where we started with 1 nitrogen gas molecule and 3 hydrogens. We ended up with 2 NH3s, 1 NH3 here, 1 NH3 here. I hope that helps you conceptualize. I will post another video in just a second of balancing chemical equations and how to do it mathematically, but hopefully this helps you with the concept. Thank you very much. See you later.